So we have talked about finding area under a curve by breaking it into rectangles. But we've already agreed that the more rectangles you have, the more accurate it would be. And I think first day Carson said it's almost like a limit. So if we did the limit as the number of rectangles went to infinity, we would get the exact answer. So that's what we want to talk about today. So if I want the exact area, we've looked at this one several times. The region under f of x equals x squared on the interval 0 to 3. So what we need to do is set up our formula for the areas, but it's not telling you how many rectangles, so we're going to use it as in rectangles. So first we need to figure out our change in x, or how wide these rectangles are. And it's just your ending point minus your beginning point divided by the n rectangles we want to use. So it would be 3 over n, which makes sense. We did the one where the width, we did 5 rectangles and we had 3/5. We did 10 rectangles and it was 3/10. So 3 over n. Our first point, I'm going to write x sub I. This is going to tell us where we start. Maybe not necessarily on this one because we're starting at 0, but it might be helpful on others. So if I start at 0, each time I will be adding a multiple of 3 over n, right? So 3 over n times, the first time I've added 1 multiple, second time I've added 2 multiples. So to get my x for a certain point, I just take 3 over n times I. So if I'm going to do these areas, we have to add up from 1 to n of the areas, length times width. Okay, my width is 3n. To get the height, we have to take whatever x we're on, so 3 over n I, and plug it into the formula, which was x squared. So 3 over n I squared. So, area of a rectangle is length times width. Right? All of these rectangles have a width of 3 over n. That's the change in x. This is like our width. These are the x values at a certain point. And remember when we did these areas, we had to plug the x into our equation. So like when we were doing 5 rectangles, we took 3/5 and plugged it in 3/5 squared. And then we added 3/5 again. So we've added 2 multiples of 3/5 and plugged it in, and then 3 multiples of 3/5 and plugged them in to get the y. So if I'm on any given point, we call that x sub I, just tells us our multiples. And I'm putting that in to replace this x. So in your function, x gets replaced with your x sub I, and that's what gives you the length of your rectangle. All right, so if I simplify this, so this would be 3 squared times 3, so 27. N times n squared would be n cubed. I squared. But don't we know how to add up I squared?
Oh, so we pulled it out.
Mm-hmm. So 27 over n cubed. Now what's the I squared formula?
N plus n times n plus 1 times 2n plus 1 over 6. Okay.
We have to memorize that for the quiz, right?
Yep.
How did you prove it by the way?
Yeah, did any of you come up with proof?
Well, I was hoping no one said that so I could do that before I left this class today, but Grant just...
Alright, have it by the end of the class tomorrow,
Okay.
so take it.
I got a
tried
little
it
busy last
on
night.
n to the cubed, and
It's hard.
I just couldn't get it to equal the that.
Okay, we need to simplify this as much as we can. So I'm going to go ahead, can I knock an n off everything? 27 and 6 would reduce to 9 halves. By 9, if I FOIL this out, 2n squared, 3n plus 1 over 2n.
Would it not be 2n squared?
Yeah.
that's 18n squared plus 27n plus 9 over 2n squared. So that's a formula. So if I gave you, I wanted 5 rectangles, we could plug 5 in here and get, I said 10. But I want the exact, so I want infinity. So now, and you're welcome to do L'Hopital's here, but somebody did catch on yesterday. Couldn't we just divide each of these by 2n squared?
Yeah, Caddy did.
So 18n squared over 2n squared is 9. 27n over 2n squared would be 27 over 2n plus 9 over 2n squared. You can certainly do L'Hopital's, but if we do this, it's not necessary because you get 9 plus 0 plus 0. So my exact area is 9.
Wow, just
Right.
Look back at
Can't be that easy. Like,
where we started. When we did 5 rectangles, we said it was between 6.48 and 11.88.
wow.
When we did 10 rectangles, we said it was between 7.695 and 10.395. 9 fits those requirements.
Why would you do the limit as n versus infinity?
If you want the exact area, you have an infinite number of rectangles here, because we talked about the more rectangles you have, the more exact your answers are. So the true answer is for an infinite number.
Wow. Nice.
That's kind of fun, isn't it?
yeah, ish. From x1.
Try another one. All right, I want the area under the graph of this function from 1 to 5. So change in x. How do we get it?
4 over 5 minus 1 over.
So just 4.
Oh, okay.
Yeah, you just.
I was
You
trying to
jumped
find the
which is-
bottom number I needed.
So a given x, keep in mind, this one starts at where? 1. So it's 1 plus however many multiples of 4 over n we've used. So 1 plus 4 over ni. That is what I have to plug in for my x to get the height of my rectangles.
Would it make a difference if you put the I on the bottom?
You don't want to put it on the bottom, you can put it on the top. You could say 4n over I. Or so 4i over n. So,
Would you need to simplify that? Just simplify that?
yeah, we can't, since it's not plus 0, that's all we can do. And so again, that 1 is because that was the start of my interval. So now if we do the sum from 1 to n, length times width. So it's just your change in x times what you get when you plug this in. So that would be 100 minus 3 times 1 plus over ni. All right. It's a little bit uglier. But it just requires some multiplication. We can handle that. So I'm going to start on the inside.
4 and I. 4 and I. 4 and I. Never mind. Ignore me. I'm lying.
I wrote
Yeah, it's
I
because
wrote
this
it wrong.
first one is just your change in x. So if I FOIL, I would get 1 plus 8 over ni plus 16 over n squared I squared. So 4 over n times, if I distribute my -3, is that going to confuse you guys if I go ahead and do, when I distribute my -3, I'll have 100 minus 3. Can I go ahead and write 20 or 97? Then minus 24 over ni minus 48 over n squared.
Oh. Where did this square, that's what.
We haven't
I
got
haven't
that
used
far
the
yet.
formula yet. I am multiplying it out so I get to the point where I can use the formula. All right. Do you want to go ahead and distribute that 4 over n? Okay. 97 times 4. N minus n squared I minus 192 over n cubed I squared.
Now we break it up.
Now we can do our summations. So I can add up each of these terms. What happens if I add 388 over n?
This times n.
Since it doesn't have an I in it, it just gets multiplied with n. Minus the 96 over n squared, you're essentially pulling that out in front of your summation. What's the formula for I?
N times n plus 1 over 2.
Minus 192 over n cubed. What's the formula for I squared?
N times n squared. No?
You're thinking n cubed.
N
Alright.
times n plus 1 times 2n plus 1 over 6. I thought you were writing a square like you were
I
trying.
started to because I looked up at my n cubed and so I was thinking about the cube formula. Alright, is everyone okay here? Let's see what this simplifies to. So 388 over n times n is 388. Okay, here 96 divided by 2 is 48. I can cancel one of those n's. So I get 48n minus 48 all over n. I distributed my 48. Okay. Cancel one of these. 192 over 6.
32.
So I get 32. I'm going to go ahead and flip over this. 2n squared plus 3n plus 1. All right. Are you guys with me so far? Ultimately, what do we have to do to this?
Put a limit in there?
So we're doing the limit as n goes to infinity. I'm going to go ahead and write my limit, and then I'm going to clean this up just a touch more. So if I break these apart, 48n over n would just be 48, minus negative would be plus 48 over n. So I distributed this negative and divided my n in that step. On this one, can I distribute a negative 32 and divide by my n squared? So that would be minus 64 n squared over n squared cancels. Minus 96 n over n squared, so 96 over n. Minus 32 over n squared.
Oh my goodness.
Lots of algebra. But we're pretty much done. Because as n goes to infinity, anything with an n on the bottom goes to 0. So I get 388 minus 48 minus 64.
276.
So the exact area is 276.
Gracious.
Goodness.
Is this gonna be on the quiz?
Be prepared.
I mean, only one.
How many questions are there?
So 7. Maybe 8. I think one has an A and a B. So, you know, there's 8 questions if you count A and B separate.
Just
Dang.
slide us the quiz while you're at it.
4 of them are just antiderivatives,
Okay,
and
get
then
some
4 of them are from this section. All right. It won't be as bad.
What is an odometer?
Measures your speed, or how many miles you've driven. Okay. So suppose the odometer in our car is broken and we want to estimate the distance driven over a 30-second time interval. We take speedometer readings every 5 seconds and record them in the following table. estimate the distance traveled. Okay,
This formula.
so distance is just rate times time, right?
Yeah.
Okay, but am I traveling a consistent speed?
No.
No, so I can't just say I'm going to take a flat rate times my 30 seconds. So what we're going to do is calculate like our over and under estimates.
Whoa.
When I look at this, we do have a problem because,
Mine is going up by 5.
yeah, and my time is in seconds.
That's in hours.
So we have to multiply by 3600.
Yeah. So that would give us a pretty big number. Do you just want to go ahead and change it into,
Hours.
Can we just change our hours to seconds?
Or why not our seconds
How about-
to hours?
let's change,
All of it.
Everything.
okay, so we have lots of options. We could change our time into hours and have some nasty
I'm
fractions.
changing both the
We
minutes.
can change our velocity into miles per second, but that's gonna be pretty ugly. What if we did feet per second? That should give us a more reasonable.
Feet per
Number.
second.
Okay.
Okay, so let's think about, you might just leave yourself some space. We'll just add another row onto this table. How about that? So let's do velocity feet per second. I'll be nicer on your homework. I won't give you any that you have to change the conversions first, but we were talking about it. It seemed like something we could do
When were we talking about it?
right now. So 17 miles per hour. If you want to change that into feet per second.
280.
Okay, there's 5,280 feet in 1 mile. That would give me feet. All right, hours. How many seconds are in an hour?
3,600.
Okay, so basically for each of these numbers to convert it, you have to take it times 5,280 and divide by 3,600. And we'll just round to the nearest whole number. So when we do that to 17, it comes out to be 24.9, so can we call it 25?
Oh, we sure can.
So 21 times 5,280 divided by 3,600 is 30.8, so let's call it 31. 24 gives us 35.2, so we'll do 35. 29, 42.5, so 43. 32, 46.9, so 47. Huh?
It's gonna be 45, I know.
45.4, so 45.
I guessed that one, you don't have to do it. The next one's gonna be 42.
41.0, so 41.
So you're wrong.
Okay. So I'm using these velocities.
Awesome.
Now we can estimate it 2 different ways. We can do the velocity at the beginning of the time period or the velocity at the end. Okay, what do I mean by that? The first time we went from 0 seconds to 5 seconds. So I can either assume I went 25 feet per second that entire time, or I could assume I went 31 the entire time, right? All of my intervals have a width of what?
5.
5. So to get my speed, I just have to do rate times time, so 5 times whatever my speed was at that time. Can I just pull my 5 out in front?
Sure.
So if I'm estimating it from the beginning of the time period, then my first 5 second chunk, my speed was
17.
25.
25
Oh,
as we convert.
yeah. Whoops.
Okay, the next 5 second chunk, my speed was,
31. We're just doing it over under.
my next 5 second chunk, the next 5 second chunk,
42.
the next one,
47.
the next one.
45.
And if we're using the beginning of the time period, do we have a time period after this?
No.
So that's our last one.
I would never have written one after that.
Like who's doing it?
Erasers are a great thing.
Uh, 113, yeah.
So that would estimate my distance at 1,130 feet. Okay, the other option is to base my speed off the end of the time interval. So the first 5-second chunk, we would base it off our speed at 5 seconds, so we would start with 31. So it's just like our over and under. The only difference is we're not starting with the first one. So 31, 35, 43, 47.
1, 2, 1.
And we would add it. This time, since we're basing off the end of the time interval, 30 seconds would mark the end, so we'll use the 41 this time. So our true distance is in between those two numbers, right? Somewhere between 1,130 and 1,210. We just found over and under estimates for the distance traveled.
North total. Oh, my second total time. I was confused. That's the end?
That's the end.
Oh, I thought we were gonna start doing summations. I was like, we can't do summations, it's not even.